do my initial slide without the slide. So thank you, Marlene. Hi, everyone. I hope you can all hear me well. My name is Annika Tönjes from Wuppertal Institut. And yeah, I'm happy to take over and start my presentation first, hoping that we can sort out the technical issues. So I will be presenting some results from a paper that I have worked on with my colleagues Katharina Knob, Tobias Lichtenböhmer, Helena Mölter, and Katja Witte here at Wuppertal Institute. And the paper was based on work from two different research projects that we were involved in. There it is. Okay, I think I can control it too. Great. So yes, so the research projects that the paper came from are the Cypher Climate NRW project and the Reinvent project. And we looked into the dynamics of cross-industry low-carbon innovation in energy-intensive industries. Let's see. This does. Oh boy. Okay. Let's go one back. Oops. This is. Anywho, okay. So I'll start with a little background on how we arrived at this topic and why we thought it was worth exploring. So obviously, while energy-intensive industries are a pretty heterogeneous group with very different characteristics, in principle, they all face the same two challenges in terms of climate action. One being the reduction of greenhouse gas emissions, and the other one being moving away from fossil feedstocks as much as possible. So we also know that incremental process innovations and energy efficiency improvements won't cut it anymore, and that these so-called hard-to-abate sectors require more radical innovation. Something we've noticed in our work on low-carbon innovation in these industries is that there are several instances of companies that have started to look across industry lines and started collaborating with actors from other industry sectors in their search for innovative solutions. So we asked ourselves the question how these kinds of collaborative innovation processes come to be, or more precisely, what are key factors influencing the successful implementation of cross-industry collaboration projects for low-carbon innovation in energy-intensive industries. So we were particularly interested in those earlier stages of the innovation process and the non-technical factors that influence it. Okay, so conceptually, we first looked at three different strands of innovation theory in the literature. First off, was low carbon innovation, which is a type of sustainable innovation that specifically focuses on the decarbonization of products and processes and the goal of GHG reduction, and to a lesser degree also fossil fuel phase out. Secondly, innovation in energy intensive industries where, as I already mentioned, deep decarbonization requires more radical innovation, to which there are many challenges that are more or less severe in the different industry sectors and include things like high capital intensity, long investment cycles, low profit margins, low end consumer engagement. The list goes on. Lastly, we looked at cross-industry innovation, which is characterized by an open rather than closed innovation approach. Oh. Seems to be skipping too far ahead for some reason. Let's try this again. Nope. Okay, not working. Anyway, so what was I saying? This does not seem to be really working. Oh, there it is now. Okay. So lastly, we looked at cross-industry innovation, which is characterized by an open rather than closed innovation approach, where knowledge is sought in other industries and which often takes the shape of innovation alliances or direct horizontal collaboration between companies from different industries. So basically the focus of our work is at the intersection of this Venn diagram, so of these three theoretical strands, where we found that prior research is rather thin at this point. Okay, now on to the next slide. There it is. So yeah, because of this and because of the nature of the research question, our approach was very explorative. We had good insights from the Cypher Climate project and a good database of low carbon innovation cases already available through the reInvent project, which we first analyzed to identify examples of innovations that fit into this analytical scope that we chose. And we wound up with 4 in-depth case studies with some cross-industrial characteristics.
Can you
hear me? Yep, we can hear you, Stefan.
Ah, great. Sorry for interrupting.
No worries.
I'm happy to be in.
Welcome. Okay. So yeah, we had 4 case studies. The first one is Enerchem, which is a proposed waste to chemicals plant that is intended to produce syngas for the chemical industry from municipal waste. So this is at the intersection of the chemical and waste management industries. The second case we looked at is Durasense, a biocomposite material which embeds wood fibers in plastic, which is an innovation at the intersection of the pulp and paper and the plastic industries. The third case we looked at is carbon to chem, CCU technology, to produce base chemicals from steelmaking off gases. So obviously this is at the intersection of the steel and chemical industries. And then lastly, and a little bit separately from the others, we have In4Climate NRW, a platform for collaboration between different industrial sectors as well as scientific and political actors. So this is in itself less of a technical and more of a social or organizational innovation, which I'm assuming many of you are now familiar with after the In4Climate side event yesterday morning. So yeah, as I already mentioned, the approach is rather explorative. So of course it has a few limitations. It's a fairly small number of cases that does not cover all energy intensive industry sectors. And many of these innovation processes are still in early stages, so there's obviously no insights yet on their actual low carbon impact. However, we have some good in-depth information from expert interviews as well as desk research. So we were able to distill 5 key factors that may influence the successful implementation of such cross-industrial innovation processes. Yeah, there we go. The first key factor we identified is the mitigation of financial risk. So radical low carbon innovation in energy intensive industries is often lacking a business case. So there's several reasons for this: high investment and operating costs, very efficient existing technologies with which to compete, which have strong economies of scale, a lack of an established market for green materials and other aspects like this. And so cross-industry collaboration can help mitigate this by way of, well, for one thing, sharing the financial risk among the different collaborators, as well as potentially involving downstream companies as customers in the Innovation Alliance. And a third factor is that large cross-industry consortia have a good chance of attracting some public funding that can also help reduce the financial risk.
Annika, just because this is a bit of trouble in the meanwhile, you have 5 minutes more for your presentation, just that you know.
Oh, 5 minutes. Okay.
Yeah, it's
well,
already, you're speaking already for 10 minutes.
Okay. All right, I will try to hurry. Okay, oops, come on. So, second factor, clear political signals. Yeah, so this is a second key factor that we identified, is political framework conditions. This is something that was repeatedly mentioned by interview partners. Companies from different industries have fairly recently started to actively seek out opportunities to collaborate, and they've been taking a more proactive approach rather than a reactive approach to shaping the low carbon transition. And the reason for this, as mentioned by many interview partners, were clear political signals, mainly the Paris Agreement, but also more precise framework conditions like the ETS, which play a key role for this shift in mindset. Then we have a third key factor, which is institutionalized cross-industry exchange. So the strategic assessment of opportunities across industry lines is still not a part of many companies' innovation strategies. And third parties like government or scientific actors, as well as other intermediaries, can play a key role by providing opportunities for representatives from different industries to sit down and discuss. And as a next step to make these opportunities less of a random one-off thing, there's the possibility of institutionalizing such exchange by providing a platform, providing neutral spaces and formats for targeted discussion and exchange of knowledge, which can be a strong driving factor. Then we have the fourth key factor, which is not coming. There it is. The fourth key factor, which is professional management and coordination. So large innovation consortia that comprise a wide range of partners with different perspective and different knowledge bases and different interests tend to be slow moving and involve a lot of bureaucratic red tape, so to speak. And so having a professionally managed process instead of more of a trial and error approach, which the literature also showed is often the case for cross-industry innovation processes. This can help organize ongoing work, reduce information asymmetries, and maintain mutual trust. So professional project management with a clear division of responsibilities is important for moving such projects along. And then lastly, we have what we call regional integration. Regional proximity of partners can be a key driver, especially with regard to physical things like infrastructure buildup or other aspects of industrial symbiosis. And even beyond that, clustering of knowledge and experience can be key because it fosters regular exchange. So exploring opportunities in existing clusters or creating new clusters can be an important driver. We also find that regional integration can be a multiplier for more cross-industry innovation, as is kind of the intention behind projects like InfraClimate NRW. So to summarize, hopefully I still have a little time to do that. We have some overall findings from our research here, which is that cross-industry collaboration can be beneficial for helping companies from different industries identify common goals and needs, and also forming new transition pathways that may have been left unexplored if each company had just remained firmly within the borders of their own industry. And the 5 key factors that we have identified can promote the initiation and successful implementation of cross-industry collaboration projects in energy-intensive industries. So we would like to see this paper as kind of a jumping off point for some further research into this particular type of innovation. So there are a number of things that future research could explore further, such as the role of these 5 and potentially any additional key factors in other cases of cross-industry innovation. So looking at different industries, maybe broadening the case base. Then influencing factors in later stages of cross-industry innovation processes, such as the scale-up phase, could also be interesting once these projects get to that stage, to see what drives them along. And then one could also look at the benefits versus the drawbacks of cross-industry and low-carbon innovation in energy-intensive industries. Obviously, in this paper, we have been singing the praises of cross-industry collaboration, kind of, but there are also potential drawbacks, like lock-in effects from industrial symbiosis and such things. And lastly, on a more theoretical note, one could try to conceptualize a more holistic theoretical approach for cross-industry low-carbon innovation in energy-intensive industries. So basically filling this little intersection of the Venn diagram that we saw earlier. And yes, that's it for now. I hope that this wasn't too quick in the end. If for any further information, feel free to visit either of the two project websites, as well as the Institute's website. And I would like to thank you for your attention and hope that I can answer any questions that you may have.
Yeah, thank you very much, Annika. That was a very nice presentation. And yeah, so far there are not any questions. Or Stefan, do you see any questions in the chat already? We are muted. You're muted, Stefan.
Yeah, but I can unmute. That's great.
Yeah.
And I don't see any questions either. So maybe it's a bit early in the morning, but I have two questions for Annika.
Sure.
Maybe I'm didn't had some problems in the beginning, but I think you analyzed the Swedish hybrid project as an example, and I mean that's
Nope.
you didn't.
I didn't.
Next question.
So have you any ideas on that project, because that's cross-industry cooperation and seems to be pretty concrete. So you mentioned it's maybe difficult when it becomes really into constructing something on the ground. So have you any ideas on that project, or are you not informed about it?
Well, we did cover that in the reInvent project. We just didn't choose it as a case for cross-industrial innovation because it was very much from the steel perspective, the case study in there. So we didn't really have this cross-industrial insight that we needed for this paper. But sure, I mean, you have physical aspects like building up the infrastructure for the hydrogen, I suppose. Yeah, I don't know. I mean, do you have any specific questions on this, or just?
No, I just wanted to know if you can give us some more concrete ideas on how it, for example, worked in this project or works in this project. But maybe I also have another one.
Okay.
I don't know if you can answer that, but yesterday in the Info Climate session, we heard from industry that is really a problem to sit together. Particularly, of course, it's more problem when there are more companies from one sector, but they have problems with competition laws. So they are not allowed to speak to each other because they are thought to heavily compete and do not tweak competition. And they said this can be a problem for their cooperation. Did you also encounter things on this issue? Is this also a problem from your perspective?
Well, from a cross-industrial perspective, this is less of a problem because you look at companies from different industries and them collaborating, and they're not usually direct competitors. But sure, if you have a large consortium that involves several companies from the same industry, this would be an issue and would add to the some things that I touched on earlier, which is things like different knowledge bases, mutual trust. If then competition law also gets into the mix, then you especially need some type of professional project management that lies outside the companies that are directly involved in the innovation process.
Okay.
Thank you very much, Annika. We have to shorten the Q&A session a bit because we had these hurdles at the beginning. So thank you very much for your nice presentation. I would have a couple of questions more, but we need to shift that to another day or another meeting. So thank you very much. Now we will try again if Magnus Andersson can join and give his presentations without any problems with the audio. So please, Magnus.
Thank you, Malena. I would just ask you to confirm that my audio is better. Thank you. Okay, I will introduce myself. My name is Magnus Andersson. I work at the RISE Research Institutes of Sweden, Sweden's research institutes, and I will be presenting a Swedish triple helix research and development initiative called Climate Smart Process Industry. It's coordinated by Johanneberg Science Park, a science park in Gothenburg, Sweden, and it's actively run by the science park in partnership with RISE through me and a number of colleagues. So what is Climate Smart Process Industry? It's, as I said, a triple helix R&D initiative. It's part of a 10-year funding model, you could say, by the Swedish innovation agency called Vinnova. It's basically a support for regional innovation within specific industries, and it's aimed at establishing nationally and internationally strong and attractive innovation arenas. So every couple of years, new initiatives gets funded, and today there are roughly 20 across Sweden. And in 2019, 3 more got funded. 2 of them deals with digitalization in the healthcare sector and the agricultural sector. And then the third one is this one, Climate Smart Process Industry, that I'm presenting. And so this initiative is physically located around the city of Gothenburg on the Swedish west coast. And the partners of this initiative are all part of an industrial cluster or network called the West Sweden Chemicals and Materials Cluster. It's a regional triple helix network centered around the petroleum and the chemical industries. It also has universities and research institutes included. The county councils are represented, as well as county administration companies, as well as SMEs. So today the cluster itself has around 40 members, which is a fairly large number measured by Swedish standards. Sorry, didn't change the slide. These are the companies involved in the clusters. So the vision for this initiative is the following. The initiative will lead a transition from an industrial region based on fossil raw materials to a region where industry is world leading in the production of chemicals, materials, and fuels based on renewable and recycled materials. So basically, the industry that I'm talking about, the petroleum and chemical industry in the region, is heavily reliant on fossil raw materials today. And so the initiative aims to transition the region to non-primary fossil raw materials. And when we talk about renewable raw materials, we talk about forestry raw materials, so basically wood. And when we talk about recycled raw materials, we talk about recycled plastics. So the financing for this initiative is the following. I'm sorry for, okay, now the slide skipped a bit. I'm sorry about that. Sorry for the Swedish numbers. In converted to euros, we roughly have 5 million euros from the Swedish Innovation Agency 3 million euros from county councils, as well as membership fees and so on going into this industrial cluster. And the budget in total is roughly 11 million euros, which again, by Swedish standards, it's fairly large amount of financing for this type of initiative. The desired long-term effect of this initiative is shown on the left, which is basically various types of innovation capacity improvements, as well as CO2 reduction goals shown on the right. Currently, the industry itself is emitting roughly 70%, or I should say the region is emitting 70% of national emissions, and a fair amount of those are coming from this industry. And so it's the hope of this initiative that CO2 reductions are reduced by a fair amount from various activities within thematic areas that I will talk about. So how do we approach this goal of transitioning the region then? We basically do the following. We have 3 types of activities or strategies. We concentrate and run, we concentrate efforts and run specific projects within 4 thematic areas shown on the right, on the outer border of that gray circle. We catalyze feasibility studies by funding our own feasibility studies or support other research applications by other people in the region. We also try to create conditions for new investments and initiatives by basically collaborating with actors within the region who fund these type of activities, as well as actors nationally and internationally. So I will mention some ongoing projects that we're currently promoting or financing ourselves. We roughly have 20 projects or activities that we fund ourselves through this initiative. And I will show you some examples. One example is this one. We basically have within each of these 4 thematic areas that I briefly mentioned before, we have various project themes. And one of them is this one, which is to develop a plastics refinery in the region. So basically, we're trying to support the development of chemical plastic recycling through pyrolysis or gasification. And the end goal here is to recycle plastics that are hard to recycle mechanically, so that we can close the loop for plastics and create circularity. So it's a method or technology that complements mechanical recycling. You can generate quite high quality products or raw materials, sorry. And you then, of course, if you increase recycling, you can have the opportunity to decrease CO2 emissions by avoiding the use of fossil raw materials. Another project theme is to establish mass balance concepts in the region. So basically supporting implementation of various standards and certification schemes that allow for basically allocating renewable and recycled feedstocks to end products. So this is quite important for the industry to create, to show to end customers the mix of various resources or raw materials in end products. So the point here is that these types of approaches allow for using existing production plants or facilities, and thereby a gradual transition away from fossil raw materials. And basically it does this by allowing for drop-in solutions, where you prevent the need to build new costly separate production plants. And typically they are aimed at accommodating both fossil, renewable, and recycled feedstocks in end products. Sorry, skipping ahead a bit. So these are some of the projects we have planned within these 4 thematic areas. If you want to know more about them, you could read the slides afterwards or visit our website. I'll not go through them in detail. I'll mention briefly a bit about how we organize this initiative. So basically, we have a steering committee shown on the top left. It's the steering committee for the industrial cluster itself that I talked about before, as well as this cluster initiative that I'm talking about. We also have member meetings for all of the members in the cluster twice annually. And then we have a central, or sort of the management team leading the day-to-day work in the initiative, of which I'm a part. And then we have working groups for all of the 4 thematic areas, as well as a separate working group to support competence development or skills development. And the point of these working groups is to meet. They meet 4 times a year, and they discuss ideas of how to develop the cluster, and they also sort of debate ideas around what projects to fund and so on, how to move forward. It's coordinated then by the management team, and then it's decided upon by the steering committee. So the point is to have sort of support some sort of grassroots innovation. And I will end on some notes on more notes on the organization. As I said, we have a management team that manages the day-to-day activities. It's staffed by Johanneberg Science Park, the local science park that I mentioned, as well as people from RISE. We manage these 4 areas, and as I said, we have working groups meeting 4 times annually. We also have a number of activities on top of that to support various innovation activities within the region. We try to work with skills development and competence, as I said, and we also have do a lot of communication and networking activities in the region to connect actors and to pick up ideas for projects and to support other initiatives in the region. And that is basically what I would like to present. Sorry, moving to the wrong slide. So with that, I'd like to thank you for your attention. If you want to know more, you can visit this URL. And with that, I'm happy to take any questions or comments. Thank you.
Okay, thank you very much, Magnus, for your presentation. I would have a question, unless there is another question in the chat, Stefan.
Yes, there is a question in the chat. So maybe we take that first. This is a very knowledgeable question, obviously, from Sweden. So, Magnus, what do you think? What will the yes/no to the expansion of the Preem refinery in Lysekil mean for the wider vision of climate-smart petrochemical industry? So maybe you also briefly explain the background to this question. I guess you know it.
Yeah, so Preem is working on extending their plant in Lysekil is a city north of Gothenburg, so they're planning to extend their refinery activities, and it's of course debated if it's a climate, so to speak, benefit for the climate or not, and you can have there's sort of pros and cons around this. So we are not actually large activities like that are of course handled by the organizations themselves, so we're not directly involved with that. We work with supporting processes and technologies and pre-studies aimed at the renewable sides. So we would look at technologies around incorporating wood stock, wood feedstock, and so on. So it's hard to say really. Of course, it will affect Preem and sort of their strategies going forward. But it's hard to say. We're not really we're supporting the region, but we're not working directly with their with their with those types of processes. So it's a little bit hard to say. That's the best answer I could give, I think.
Mm-hmm. Okay, thank you, Marlene.
Yeah, I would have another question. So this hybrid project was mentioned already, I think a few times this morning. So can you compare the hybrid project and your project concerning its advantages and disadvantages, problems or opportunities, or what could you learn from hybrid, or what could hybrid learn from your initiative? And what do you think, which initiative will first reduce the CO2 emissions close to zero? Will it be hybrid or will it be you?
I like that you put it as a competition. And I think we both do good things. And of course, hybrid is also very much a larger project than ours. And I don't have any insights either, really, to hybrid. They're very secretive about what they do. But I think the thing I could say is that both projects work towards are very sort of applied, and both are aiming to build and test new processes, pilot plants and so on. So those are the similarities, I would say, but they are of course very different in what types of processes we are aiming for. I would say any steps forward in these they're very different industries also, but 2 steps forward in reducing the use of carbon in the steel industry, which is hybrid's goal, is very, of course, positive, and also a step away from using fossil raw materials in the petrochemical industries are also very important, but they are very different. So I wouldn't say there is any competition really, or sort of a winner or losers. It's just winners overall if you could take steps forward, I would say. And
on the timeline, what do you think? Did you mention already when shall these CO2 reductions of 17% of the national CO2 emissions be reached with your project?
We will not reaching to meet sort of, or to reduce all of those emissions. They are sort of the emissions from the region as a whole. It's hard to say, of course. I don't think that this project is not nearly enough by itself to reduce these emissions. We, as I said, sort of aim to initiate pre-studies and so on to create snowball effects and so on. But then it's up to also, of course, the industries themselves to make very large investments if this is going to work. So about the timeline, I would say 10 years. It's very ambitious, to say the least. I mean, many of these large transitions could take 10, 20, or even more years. So hopefully we can contribute to a step forward.
Yeah.
Maybe another question from here, from my side, Marlene, if you allow.
Yeah, another 2 minutes.
Yeah. Good. So I try, maybe I miss it, but is there also a sort of a roadmap also in your project? So in order to reduce emissions, or is it mainly to explore and start pilot projects? That would be very interesting.
I have a trouble hearing your question. If you could sort of briefly
I can repeat
it.
Yes. So the question is, has your project a sort of a roadmap? So how to reduce emissions in a big volume in your region or in the companies involved? Or is it mainly about research and implementation of pilots?
Again, I have some problems with the audio, but I heard something about, like, do we have a roadmap? And I would say that we are aiming first to do sort of pre-studies on the amount of resources that could be used, so collecting data and knowledge. And then we are aiming to, on top of that, we are, after that, we try to do more experimental work to prove sort of and test out technical processes. So stepwise realizing and moving further to actual implementation. And we're hoping that that will have some, and those processes can be picked up by industry. So that's basically the roadmap, I would say.
Okay, good. Now a last question came, but maybe it's
Stefan,
a little too complex to really go for it. It's on, yeah, the competition between chemical and mechanical recycling.
Stefan,
but maybe
sorry,
you can answer that afterwards.
Yeah, I would propose maybe we can put that into Woover, and then Magnus, maybe you can write a reply in Woover, because now we need to hand over to the next. And so thank you very much for your presentation, Magnus. It's a very great project, and we will see how it will develop in the future. So the next presentation is from Stefan Buettner, and with that I will hand over to you. Welcome, Stefan.
Good morning, everybody, and it's a pleasure to be here, even though in person is completely different as virtual. However, we may have a wider reach this way. My name is Stefan Buettner. I'm working at the Institute for Energy Efficiency in Production, and I'm presenting now today on how companies react on the rising societal pressure and the emerging policies. The data that we have gathered is focusing on Germany, and now we are going to dive in what measures companies do take to tackle their footprint and why. More or less exactly 1 year ago, we had a situation with the Climate Week coming up, the UN Climate Summit in New York, with the height of protests increasing, Fridays for Future, Science for Future, the Scientists for Future, and more pledges were made in the weeks to that meeting in New York City. That inspired us. So what impact does it have on companies? Are they reacting to this? Are the statements that politicians make true, that situation is like X, Y, Z for companies? And that inspired us to dig deep into these questions and find out a bit more about the real situation, because undoubtedly we need to do something about decarbonization. Now, looking at the workforce, we know the young people were on the streets, but also others. A study found that nearly 70% of young graduates value the environmental consideration of future employers higher than the starting salary. And even amongst existing workforce, this factor becomes increasingly important. Also, what we do note is that the price of the emissions trading scheme in Europe is rising, and there are discussions to expand the sectors that it's valid for. Also, Germany is putting in place a price on carbon starting in the beginning of 2021, potentially costing millions to industry. There, I need to add that the factor electricity is already covered through ETS, so it's all non-electric emissions that are affected by this. Now, looking at German industry itself, it accounts for nearly 18% of energy-related emissions in Germany. When we look at total emissions, that figure raises to between 20 and 25% of total emissions. And these total emissions are 2/3 energy related for the industrial sector and 1/3 process related. Unless in many other sectors, and we have the advantage in the industrial sector that entrepreneurs take investment decisions, replacement decisions, product decisions on a daily basis. So whatever happens here can be really impactful. Now, looking at the size, we do have 3.3 million companies in total in the country. 540,000 of those are considered manufacturing, with a revenue of 3 trillion euros and about 10 million staff. However, actual manufacturing is a smaller number, and it's just 178,000 companies spread across 27 different subsectors. Now, what is the goal that we're aiming for? It's avoiding climate change. And there we have, not only because of yesterday, it started with the Paris Accord a few years back, the notion of we need to limit warming to 2 degrees, ideally not more than 1.5 degrees. And we want to decarbonize Europe by 2050. And as of yesterday, the plans on the road there were tightened. So in the State of the Union, Ms. von der Leyen stated we want to reach 55% reduction already by 2030. Is that feasible? How do we get there? There were already quite strong media and politicians' reactions on that request. Now, how did we find out more? Certainly the inspiration was the public opinion last year. We used the energy efficiency index of the German industry, which was put in place in 2013 to take the pulse of manufacturing. So what's really going on in the industrial place? What do entrepreneurs think? How do they assess and value things? And what are they planning to do? In the short run, in the long run, on the policy assessment side, but also on what do we value or emphasize on when it comes to technical measures. The study and the data that I'm going to show you was taken in October, November last year, so right after the New York Climate Summit. And the particular importance was placed on that iteration on decarbonization efforts. We had slightly more than 900 companies participating, spread evenly across the company sizes that you can see here, and also distributed across all sorts of energy intensity classes. Only there were very few very energy intensive companies, so we won't discuss that fifth category of energy intensity throughout this presentation, as it's only 10 companies. Now, as I started on, how do companies react and what measures do they undertake to reduce their footprint? And we noted that on average of all measures, the majority, so 54% of answers said internal measures being on-site efficiency increases, but also on-site generation of renewables. And we also see that, for example, compensation measures or requirements to the supply chain are much, much smaller in that contrast. And there's only 1% of companies that doesn't do anything, which is a good message. There are only minor differences when it comes to company size. So the larger a company is, the more energy efficiency plays a role. And with energy intensity, if you're energy intense, obviously that is also one of the points where you can cut most costs. Looking at the manufacturing sector is, however, very interesting. There we can see that the categories of other manufacturing, coke and refined petroleum sectors, they focus most on efficiency measures, simply because energy is a very big factor in their operations. In the paper, you will find much more detail and explanation on the other forms, such as why is the charge for other manufacturing so high for purchase of renewables, or why is the charge so high for CO2 optimization of the supply chain. I can't go in that detail on each of the slides, but you're very welcome to have a look at the paper. Now, if we go one step further, we know, okay, they're doing something, but how does it look when designing new products? We have operations, yes, so how do we manufacture? But if we look in the future, products that end up in all the sectors are designed and decided upon and manufactured and sourced based on the decision of entrepreneurs. So what is put in place in all the sectors from now to 2050 has been on a drawing board or will be on a drawing board in a factory. So therefore it's of crucial importance to see whether the footprint is considered just in terms of production or also in terms of the entire product life cycle. As it is with surveys, we noticed a weakness of the question afterwards, and that is whether or not entrepreneurs or people responding considered production part of the entire life cycle or not. At least we can see here now that this being a multiple choice question, there is a big share of companies considering it in terms of production itself, but a large share already for the whole life cycle. Looking at the different company sizes, we see significant differences. So whereas micro and small companies fall back when it comes to consideration and production, they lead the pack when it comes to the consideration of the whole life cycle. And just the third factor, the footprint, is decreasing with size in total. Looking at this from an intensity perspective, we see again that the life cycle and the production consideration are fairly even amongst energy intensity classes. However, very energy intensive companies fall back drastically, and the 24% here are stating, I'm sorry that this is lost on the chart, are those not considering either. Not considering either, they consider the footprint. The reason for the footprint is that the very energy intense companies fall under the ETS regime and therefore naturally optimize for that. Looking at the highest priority, we see that on the left-hand side, by company size, that micro and large companies place the high priority on energy efficiency. And on the right-hand side, and that by far, and on the right-hand side, we can see that the less energy intensive sectors place a higher importance on the energy consumption. But here the differences are much less severe. Looking at this from a sectoral perspective, we see perhaps the biggest contrast, looking at the coal and mining sector, that here energy consumption doesn't happen. Now, why is that? This sector is tiny. It just has 7 companies. We did consider it because more than 50% of those responded, and naturally they do most things not with electricity, and therefore it's harder to change something on the energy consumption side. So it's more about resources and footprint in general. Looking at the next step though, or the big picture, what does that mean? Are companies daring to go that far, that they plan to make their company net carbon neutral or even climate neutral? So positively, 60% of companies did state, and that was ahead of Corona, that they plan to decarbonize. And more than half of them already stated that they started implementation. Some of them are already done. However, net carbon neutrality is the figure, not carbon neutrality. So you can compensate and you can do other means to get rid of your emissions that you cannot get rid of otherwise. Going to the consideration of the company size and the energy intensity view of this, we see that the large companies have leapfrogged, so they are far advanced, whereas it's the smaller companies, for example, the small companies here in this instance, that they plan to decarbonize completely. Overall, of the SME and large company sector, we have more than 60%, only micro companies fall back quite a big time, which means they need support on that path. Similarly, it looks for the energy intensive companies. It's very tricky if you have a high proportion of process emissions that you could only get rid of with very, very cost intensive and technology intensive means, such as changing the way you manufacture things completely. Looking at this from a sectoral perspective, we see that the charts or the bars are very different. So the situation in each of the sectors varies a lot, and therefore the recipe to get to the goal, it differs per sector quite a bit. Again, there's more detail in the paper on that. Sectors that refrain from, in majority, going for zero carbon are those that have difficulties. On the flip side, the automotive sector is the one that plans to decarbonize most, and we're going to go back to that in just a second. And that is by when? We have heard the 2050 goal.
I'm sorry, just 1 second. Your time is up actually. So if you could finish within the next minute.
Yeah, sure.
Yeah,
sure.
thanks.
So we have seen that 2/3 of the company plan to be zero carbon within the next 5 years already, and 90% by 2030. And as Bosch said last year, we cannot do right now. Why not doing it right now? So, and therefore, how to do it? Yeah, so there are bottlenecks. The suppliers are under pressure. If you just put pieces together and externalize the requirements, that will become an issue for suppliers. Also, if everybody goes for the easiest way, swapping the energy source to renewable electricity, there will be at one point not sufficient amounts of renewable electricity around. And also, whether or not something happens hugely depends on the institutional framework and the cultural context within which a company operates. And therefore, what does decarbonization mean? Is it zero carbon? Is it zero emission? Can I do it? How do I prioritize? And how much can be done on site? How much do we put a pressure on the system? Like, I want as many renewables, but if there aren't sufficient amounts of renewables, we cannot do that. So what's needed? And this sort of questions we have already asked German companies. The other questions you have seen a glance of, we are going to ask many more companies, and therefore I'm very pleased to launch this questionnaire, all these questions today in up to 88 countries. And I would be very pleased if you had the ability to share the word. Many thanks.
Okay, thank you very much, Stefan, for this very insightful presentation on the German industry, and also interesting to see that you want to expand that to a lot of other countries in the world as well. So, Stefan Lechtenböhmer, are there any questions to Stefan Buettner in the chat?
Thank you, Marlene. I have a couple of questions. None so far in.
I would also be, but I need to point out we have just 2 minutes left for the questions. Then
we take you first, Marlene.
So I would be happy. Okay, so just a brief question. You said 36% consider the entire product life cycle when they develop a new product. Mm-hmm. Just a very brief answer. What do you think what would be needed that this share would be expanded, that more of the companies think about the entire life cycle?
There are two dimensions. Number one, regulation. Regulation meaning having to put on a label of the total emissions. So that can either be on a product base or in line with this new CSR guideline, where unfortunately only companies with a size of 500 plus have to state figures, one of them being the total emissions. And total emissions would include those emissions as well. And the other one is company culture.
Okay, thank you very much. I think this brief question and brief answer leaves space for you, Stefan Lechtenböhmer, for a question.
Yeah, okay, I try to be quick. In one of your slides, you had a number of companies saying no, they cannot go decarbonize due to technical reasons. Yeah. So maybe this is the most concerning part or the most heavy. Do you have any ideas on that? Or in brackets, did you invite them for the eceee?
Well, this questionnaire is anonymous, so we couldn't directly do that. However, we always aim after a questionnaire to find out why answers are like that. So we can assume or we can ask, is it like that or like that? So on those who say they can't, there are technical reasons, there are economic reasons. So if we have the price on carbon, economic reasons will certainly become viable at one point. If it's technical, the question is, and I'm glad that we'll hear about this in a second, there's also some tactical statements. Yeah. So for example, if there's an exemption from ETS, it doesn't make sense now technically, but if that exemption from ETS ceases to exist, the price increase will be so drastic that you do have to go for a completely different technology, such as hydrogen. But I won't give away which sector.
Okay, so thank you very much for your question.
More on the paper.
And yeah, and there is another question. I think it's in Wuppertal as well, so you're invited to answer that or in a written way. And
I will. Thank you.
So because now it's the, thank you very much, Stefan. So now it's time for Xianli Zhu from Denmark and for her presentation on the iron and steel sector and the supply chain. So welcome, Xianli Zhu.
Thanks a lot, Malin. Yes, I think this is really a good flow of information from the EU perspective to UNECE, a global perspective. I work at the Copenhagen Center of on Energy Efficiency. We are part of the Denmark Technical University and the C4 Energy Efficiency Hub. So our mandate is really working a lot on developing countries, how to work on supporting these countries in energy efficiency and achieve the energy efficiency target of SDG 7. I will talk a little about from the global perspective, how can, what about the iron and the steel industry, how this kind of decarbonization can be achieved as the issues of policies and the solutions. Yeah, I have problem change the screen. Can you help me, Abina? Yeah. First, I will give a brief overview, then talk a little about the emissions, energy consumption of the iron and steel industry and the technologies, and also a few main countries, what's their main policies and how the international governance. Next slide, please. Yeah. Despite that globally the technology progress, still we can see like globally the iron and steel production since the year 2000 has more than doubled, and the total iron and steel production, and also there's it's still a major industry in terms of the GDP contribution and 39 million jobs through this global supply chain. And the energy efficiency, you can see still currently around average each ton of steel production, we still consume globally around a half ton oil equivalent of energy and 1.83 ton of CO2 emissions. Next slide, please. And also the worldwide, the iron ore reserve mainly concentrated in a few major countries. So there's the export rate of iron ore is quite high. But if you see the iron and steel production and consumption, in most cases, the majority is local production, local consumption. International trade only about 1/4 of the total production. And also one major driving factor is the urbanization and the industrialization. So globally, the developed countries per capita iron and steel production remain relatively stable and are gradually declining. China's iron and steel has been production has grown a lot in the recent decades, but they are around peaked, and the future expectation projection is that the main iron and steel production and consumption will mainly take place, the increase will be in India and some African countries because their rapid urbanization and industrialization. Next slide, please. Yeah, this is an overview of the global world steel exports. You can see it's a lot, as many different products. It's not just the raw air and steel bus. It's a lot, many actually different products. Next slide, please. These are the main exporters. Also include some indirect exports because that's our products, and some are even components in products. Next slide, please. So this is about the future projection. You can see like about China's production. A lot is more or less projections like this trend is quite how to say flattening now. Is a future increase, maybe very quite limited, and the main growth will be especially in the South Asia and Africa. Next slide. Yeah, globally, the iron and steel industry around 5 to 7% of the global emissions, and it's really depend on a few factors. Why some countries emit more, or some factories emit more, is the technology, is the product mix, and also some capacity utilization. When there's especially the market is demand is not so high, there's a low capacity use rate, and also some loss on the price of energy, and also the boundary definition in different countries that can be quite different. Next slide, please. The technologies generally can be grouped into 4 categories: resource efficiency, energy efficiency, or the renewable or low carbon energy, and also carbon capture and storage. And the last is recycle and reuse. Next slide, please. The international governance is, still, because this kind of concern about the economy and the jobs, so there's still in many countries like very strict rules or very high ambitions on this sect, on the air and steel industry. The China and the EU ETS have covered the air and the steel industry. Some cases they are also worried about international competition. So, and also for the US, we all know that they withdrew from the Paris Agreement, mainly at a state level. India, they have this PET system scheme for air and steel industry, started in 2014. They are continue the 5th cycle. It will be in 2022. Next slide, please. In the EU and the US, let's also talk about border tax, use border tax adjustment to protect local industries and also force the other countries to follow suit, reduce emissions and energy intensity. EU is also in the Green Deal also about this border tax, carbon border tax. We do also know like carbon border tax is difficult to implement also from this aviation emission tax back in 2012. And also the US is using the tariff, import tariff, but that cannot be really a carbon tax. It's more a normal tariff. Next slide, please. Internationally in climate circle, we also have this sectoral approach because also actually for air and steel, maybe if we have a sectoral approach, it will relevant to fewer countries because many small countries do not really have a air and steel industry. And also in negotiations, we do have this international aviation and international maritime. The difference is like we do not really have a very strong international UN body to implement such international sectoral scheme of sectoral agreement. So for aviation, we do have this ICAO, For maritime, we have the IMO, both are UN organizations, so they are more powerful. The World Steel Association is more for data collection and publishing, do not really as powerful as the UN organization. Next slide, please. The conclusions is really we can see in developed countries a lot being done doing technology innovation and policies, but that in the future and still will be an issue, like a lot of production will be increasingly in some less developed world or countries, and this carbon leakage and the market share job losses make the developed country also a little concerned about how the actions they can take and also how to use that, but practically carbon border tax is also complicated when there are so many different products and different countries, different each set have can be quite different in emissions footprint. So how can we really coordinate and motivate all countries to do the decarbonization? Thank you. Yeah, that's my last slide.
Mm-hmm. Thank you, Xianli, for your presentation on the global steel industry and how to tackle the CO2 emissions from this large emitter. So again, Stefan, are there any questions from the audience?
Yes, so far I don't see questions in the Q&A, but sometimes it's not updating properly. So maybe we can, if anybody else sees questions, just help me with that. Yeah, event support F5. I don't have F5 at my computer. Sorry for that. So if there are any questions, please try to make me aware of them, or Marlene. Maybe in the meantime, I try my own question. So thanks a lot, Xianli, for that very interesting coverage of the problem of steel industry decarbonization. I would be curious on the issue with patents that you brought. Do you know more how relevant that is? And I mean, developing countries, on the other hand, produce more than 50% of the steel globally. So and European steel producers, for example, fear anyway strong competition. And do you see any ideas to overcome this problem?
Yes, I do think that, thank you, Stephen, very interesting question. We do think like technology is very important for the decarbonization, but it's also reality. Most technology innovation are in the developed world. How can we really through this, how to say, maybe licensing or some collaboration to make this globally, we can decarbonize quickly for the industries.
Okay, thank you.
There is now a question from the audience. Thanks,
yes.
Adina, for sharing it. So someone, I don't know who, wants to know your opinion about the carbon border adjustments. Do you think it is a valuable tool, or do you think it's rather a dangerous measure with regards to trade restrictions? So do you think the countries should follow up on these carbon border adjustments and try to implement them, or do you think this will not be a fruitful policy?
I think this policy, maybe there are, the expectation needs to be, how to say, not so high, because you can see if you, we, from the presentation of the international data is most of the iron and steel industry, there are productions for local consumption. So if you iron and steel, this border tariff adjustment is mainly for the export. So only for countries who are really aiming at export. But I think this is an interesting tool to does give some motivation, like for countries, developing countries or the exporting countries to take more seriously about emission reduction.
Okay, thank you.
Okay, so now there's another question. It's from the panel, and the question is: do you see whether steel companies aim their hydrogen transition only 2030, as they have no interest to do it earlier due to the ETS exemptions? So this is a very European question. Do you see problems with the existing regulations and, as I understand it, blocking conversion of steel industry?
I'm not so, how to say, familiar with the EU part of this policy. Maybe one other panelist can help answer this question.
Stefan, maybe you should jump in and try to give an answer on that question. But maybe then we switch to yeah, no, I'm not sure.
No, I can try, as at least I don't see any other questions
there is
currently.
another. I know.
There is?
I would have another, so.
Okay, then put your question.
Okay, my question would be, I think you, in the end, you came up, if I have understood you correctly, that sectoral approaches would be a good solution probably to solve the deep decarbonization issue of the global steel industry. So, and yesterday we had this presentation from Austria where we have seen that much of the industry decarbonization problem is caused, in Austria at least, by the steel industry. So that was the question yesterday I have not posed, but on the sectoral approaches, what do you think are the strengths and what are the weaknesses of a sectoral approach? And what do you think, how many countries should join for such a sectoral approach? Should it cover the entire global steel industry, or would it be enough if a couple of countries agree on a sectoral approach, for instance, just for the steel industry?
Yeah, this air and the steel industry is quite broad. That's a definition. Definitely, that's, I think in the detailed design, it really depends on the number of companies and the level of emissions, how to balance that, whether have which companies to cover, which industrial process to cover. But it's worthwhile to think when the, as say, for this big, smaller number of countries, maybe that can make it easier for technology collaboration or policy coordination.
Okay. Thank you very much.
Okay.
So, Stefan, do you have another question? I think we have another 2 minutes for Xianli, and then we could
Yes.
switch to a final question we have not answered before.
Okay. There is something in the chat about the question from Timo. I'm not aware of any of these questions, and the questions come without names. So, Abner, if you can make that more precise. Otherwise, in the meantime, I try to give my answer on the steel industry and the European emission trading system. I think, of course, we are, as Xianli rightly told, in an international stalemate, so to say. Everybody fears everybody, competing them out. And that leads, for example, to this free allocation in the ETS to the steel industry, which is declining, however. But as I see it, all these exemptions that we give, so free allocation, are in fact also a sort of a barrier. If now we want to implement measures to support them to go to hydrogen, they often interfere with the exemptions in the ETS system and makes it even more complex to get the right regulations done. So you are hitting on an important point, but simply removing free allocations probably also, as Xianli made it clear, not easy if it is not successful to do that somehow in a global coordinated way. So, okay.
Yeah, so maybe we'll find the question.
I have a question from Xianli now. It's on petrochemicals. I guess we have time to post this question. If nobody finds the one from Timo, seems not to be.
I think it was this one on the chemical recycling for plastics that cannot be mechanically recycled, but the experience with incineration has been that it tends to compete with mechanical recycling, I guess. And then there was not.
No event. Abuna just posted it. The question from Timo was not answered really. So that was to Stefan Buettner. How did answer differ between EU ETS and non-EU ETS companies? Yeah, so maybe we take this first, and maybe Stefan, you can briefly tell us something on that.
Yeah, sure. I responded to that in the chat. Companies that do fall under ETS are typically from specific sectors and from specific sizes, and those significantly more often look at the factor of the carbon footprint.
Okay.
Mm-hmm. And on the other question, this petrochemical thing, if I shall, we did, and we only have data from Germany on our website, look at the motivation. So why are companies doing it? And how do they prioritize measures? As per this questionnaire, we aim to find that out, for example, also for the region that you mentioned, was it Singapore, right? Yeah.
Mm-hmm. Yes, thank you. Okay. And Xianli had another question. I think we still have time for that. It's on the technological transfer. So the question is, how could technology transfer be organized? Does anybody have an idea about how it has been handled in other sectors? So that's to the whole panel. And for all the others, you can also write your comments and answers in the session Q&A.
And if I think about, for this technology transfer, I feel like a lot is, we also work in the UN, the climate, also work on the UNFCCC technology transfer. It's more on the capacity building, identify countries' needs and the policy improvement. But if you think in practice, it's a lot actually through FDI, the local investment from developed countries. I think China, if you think the technology actually improved a lot in the last 2 or 3 decades, it's a lot actually through this joint ventures, FDI, this, also this personal exchange that get countries really quick learn from the new technologies, and also through collaboration investment to get this technology really diffusion or spreading across in the developing world.
Okay, thank you. So
thank you very much.
You answered your question yourself.
Okay, I think, Stefan, shall we finish this session and
yes, we
go into
should.
the break already? We have just 2 minutes left, so maybe we finish here. What do you think?
Yes, I think thanks a lot to everybody for those interesting questions, and sorry for some problems to really get them always on the screen, but I think now we got all of them answered, and still there is the Q&A open, so you can also discuss there about the questions. That's sometimes also very interesting. Thanks a lot for that, and from my side, see you back soon at 12 in our next session.
Yeah, from my side as well. So thank you very much to all the presenters, to the audience for the questions, and we hope to see you back at 12, so in 1 hour. Enjoy the break and see you later.
And I think it will be at least as interesting as this one, because it's on policies now.
Yeah, that will be also very interesting. So have a nice break and see you all.
See you. Bye.
Bye-bye.
Thank you.